Welcome back, chat. Today's lesson will leave you unchopped, just for the record. I don't think that's a thing, high key, but chopped is good or bad. But cooked is also bad. But cooking is good. All right. All right, chefs, let's do it. Cool. So, looking at this, the bell ringer for today. Normally, like if you're absent and watching this, you do not have to make up the bell ringer. But if you want to work through it, here it is. It's a good nested chain with a bunch of them. We're gonna work through it. Sweet. So we're trying to find the derivative of sine of cosine of sine of x squared. Gross. Is there a clear most outside piece right now? Sine. So what do we do with the clear most outside piece? Let's take the derivative. And I'm going to copy and paste this on the other one so that it's easier for me to work with. But here we go. Is the sign going to be like, nope. I was expecting the size to be way different. All right, so I will take the derivative of the most outside piece. And we all know that the derivative of sine is cosine. Do you want me to write the ddx's as we go through? Okay, so if you don't have to. What's the argument of this cosine? The cosine of the sine of x squared. And I'll just make sure that my parentheses match. 2 on the right, 2 on the left. I'm going to make that last one larger so it looks correct. There. And then one more big one. There we go. Okay, times. I now have to take the derivative of what? So it's this whole piece inside, right? It's the cosine of the sine of x squared. Okay, now these problems are awesome, just examples of perseverance, right? Like there's nothing crazy hard that we're doing except writing a bunch. If I were to do this derivative, there's a 0% chance that I'm going to have the ddx, but there's also a 0% chance that it would take another line. I don't think I would. I think we can probably, and most of you also, if I just pretend I didn't write this blue part, if we just went forward, can you tell me the derivative of cosine? Okay, so it would be negative sine of x squared, right? And then I would look at that and I'd say, oh, sine of x squared. What's the derivative of sine, the outer piece now? Cosine of x squared times the derivative of x squared. And I just would push through it in one line is how I would normally do it. If you're not there yet, that's okay. I'll probably mix and match whether or not I physically write the ddx and see it pushing through. So there's our first step. That's all fine and dandy. Luckily, I'm on a computer and I can do this. This doesn't change, right? Like we're already done with that piece, but it has to come along for the ride. So here it is. Now we're just going to kick through to each separate part. And let's see, what's the outer piece here? So cosine is the outer piece and its derivative is negative sine. I'm cool with that. And what's the argument of this negative sine? The sine of x squared. And then I'll do this again. The derivative, what was the inside of that? The sine of x squared. Now, I do like to write the ddx, especially when learning it, because it physically does just get pushed through the problem from left to right. Okay, am I going to touch anything in red anymore? Nope, it's all simplified. It's not simplified, but it's all already done derivative. Cool. So here it is. And lovely workout here. This very last piece, we have another chain to do, but we're almost done with it. What's the derivative of this sine? The cosine. And then what's the argument of this cosine function? X squared. And I'm not going to write this one, but I'm now going to take the derivative of what? X squared, and that is 2x. Now, this is an awfully ugly problem, but we're done at this point. Is there anything that you guys see that you look at and go, I would very clearly rewrite it and change this piece? Any part of it that stands out to you guys? This negative is what stands out in my head right here. What would you, anything that we could possibly connect it to make it look just kind of nice? I'm going to connect it with this piece. So there's no right or wrong here, just for the record, right? Like we all view this differently. It's not an agreed upon, this is a nice format of it. In my head, I don't want a negative stuck in the middle because I want to just be able to write them next to each other for multiplication. I'm going to move 2x times negative sine to the front. And my very first expression then, in my version, is negative 2x sine of the sine of x squared. And then I see that I have a cosine of x squared. Sure, there's no real order to these. X squared. I'll put parentheses around that one too. So I've gotten that. I've gotten that. I've dealt with that. What's the only piece I haven't dealt with? The cosine of the cosine of the sine of x squared. And they're ugly, like 100%. Guarantee this would have a real life application. I don't know off the top of my head what it would be. My guess is something periodic. So whether it's a spring bouncing or a planet revolving and doing some wonky stuff as it flies through space, there is a real world phenomena that would be represented by something like this. Cool. Long problem for sure. Super hard. If you persevere and you can push this ddx through, and if you physically write it, this problem should not be wildly difficult, but it's ugly. Like, there's no getting around that. All right, cool. So let's check out the assignment, and then we'll kind of see where we're going. We're going to do a little bit of calc today, but I'm also open if you guys are interested. I prepared a Jeopardy for my pre-calc class that I'm happy to try out with you guys. Okay, it might be really disheartening because it's all the really specific factoring and PQ lists and stuff, but I'm game if you are. Cool, the factoring part would be good. We'll see where we get in the end. Let's knock out the assignment. Assignment kind of hard, some of them at least. 55, and 53. Let's check it out. Okay, on number 5, did you get 3/2? So they could be wrong. Is this the right thing right here? 3x minus 2y equals 3? That feels implicit to me. That's not the right one? Ooh, let me see if my book has the same thing or where we're wrong. 3x plus 2y. So let's see, it's negative 3/2 then. Okay, I'm fine with that. Interesting that the solutions manual is wrong. That might be the first time I remember it happening here. Number 7. These look very different to me. Did you get negative x over y? Okay. Do they say skill? It does say skill building. Cool. 11. Gross. Negative. I don't know where your negative is, but I would have it in the numerator personally. Cosine x over e to the y for number 9. Cosine x divided by e to the y. Thank you, Bea. Number 11. Negative, and I would have the negative upstairs in mind, but negative e to the x plus y divided by e to the x plus y minus 1. I'm trying to see what you could possibly have different if you had done this. Yeah. So e to the x plus y equals y, right? And I'm going to kill all the implicit differentiation stuff on the screen. They gone. Cool. E to the x plus y equals y. This is number, which one? 11. Okay. So I'm going to differentiate, right? Now, I might have shown this yesterday to everybody, but this is the operator notation for a derivative. And if I take the derivative of the left, I also have to take the derivative of. Okay, I'm going to be lazy. Does that tell me to take the derivative of all of it? I'm cool with that. This is a chain rule. And all I've done here, Kalisha, just because I can't tell, instead of writing ddx on both sides, I just said take the derivative of all of it. Okay. What's the derivative of e to the u? E to the u is the first part, so that's nice. E to the u is just e to the x plus y. And then I need to take and multiply by the derivative of this with respect to x. And that's the most important part, that if you're going to get goofed up, it happens there. What's the derivative of x with respect to x? 1. What's the derivative of y with respect to x? Y prime. Equals y prime. Now it's just a matter of solving. I need to get all my y primes on the same side, right? But unfortunately, this term is stuck on this side via the operation between these, which is what? Multiplication. Now, if you try to divide both by this right off the bat, you now just have that stuck, instead of to this by multiplication, it would be stuck over here by division. We don't want that to happen. How do I make it so it's no longer stuck inside these parentheses? Yeah, that's what it's telling me to do. Let's just distribute it. We get e to the x plus y plus y prime times e to the x plus y equals y prime. Cool. I need to solve this thing for y prime. I have no real strong preference. For whatever reason, I do, but it's not what I'm going to do here, I don't think. In my head, I want to subtract this over and subtract this over, but there's no reason to that. That's just extra labor. Can I just move this piece over to the other side? Like, that's the better, more efficient way to do this. So let's do it. What? E to the x plus y equals y prime minus y prime times e to the x plus y. Dang it. Well, now I have them both on the same side, but I want to solve for y prime. How do I get that? Yeah, we'll use the f word. Here it is. We'll factor it right out. Y prime, what stayed inside? So there's definitely a minus e to the x plus y, but you forgot something, JJ. 1. Okay, still equal to this. And we're one line away from getting to our solution. What's the last step that I don't think I need to write down? We're going to divide by this piece. And here we go. And I wonder if they had a typo. Looking at mine again. I lied. I'll write it. I'll just divide by them. And maybe we have a slight typo in the solutions manual, and we shouldn't just blindly trust it. Y prime, I think, is equal to e to the x plus y over 1 minus e to the x plus y. And I want to check their answer. We have the same answer. We do. We didn't write it the same, but we do. If we factored a negative out of this, it'd be a negative out front, and then negative and a plus, right? E to the x plus y minus 1 is how we could relate that. When they solved this problem, we have the exact same answer. They did what I was commenting here, where they subtracted this one over to solve it, and you got an extra negative out of the deal. Cool. We have the same answer. Sweet. All right. I do still trust it. Feels okay. If you made a mistake on that one, where'd it happen? I heard somebody say they forgot the 1. Natural. This one, that derivative. Anybody else want to speak up? Okie dokie. Number 13, negative 2y over x. Cool. Number 15. Bummer. Why not? Oh, that's a good problem. Okay, they're all good problems. That's not fair. This one's not very good looking. Gross. I am hopeful, and I'm trying to see if there's a way that it could shake out differently. I think this is probably what you have. E to the y sine x minus e to the x sine y all over e to the x cos y plus e to the y cos x. They are very gross to check.
I said e to the y and e to x equals e cosine or minus cosine of y sin of x.
So I can't follow any of that, just so you know. But if you circle it, we can take a look at it. Like I'll come circle it on your homework so I know to take a look. Cool. All right. Questions on 21? Are we cool to keep kicking? Okay. And like we have so few people, we're more than half right now. But like I'm okay if we want to work through any of these that are particularly gross. 23. Negative, again, mine would be in the numerator, I think. But negative 6x times x squared plus y squared over 3x squared plus y squared minus 1. Blech. The good news is they're harder for me to read than I think they would be to just do. Yeah. X squared plus y cubed equals y. Love it. Already forgot it. X squared plus y cubed equals y. Whoa, nope. Here equals y. I don't know what. Weird. All right. Is that correct? That's what's on in your notes, in your problems? Yep, cool. All right, I'm going to begin by taking the what of each side. I'm going to take the derivative, and I'm going to use my lazy notation because I like it. Derivative with respect to x of both of these. Okay, immediate. We have to. So if we're doing implicit differentiation, there is like a 99% chance that we're going to chain rule it. We're going to have to. The only time you wouldn't is if y was just standing alone somewhere. So like x squared plus y equals 3. You could easily solve this, but if you didn't want to, it'd be 2x plus y prime equals 0, and you would not have to use a chain rule in that one very specific situation. Pretty much every other time will be a chain rule. Like almost every single time moving forward, it's going to be a chain rule involved somewhere. Okay, so check it out. What's the inside and outside of the left? So I heard x to the cube. I don't know that I see that. Can we all agree that this is u? Like, and it's weird to talk about it. The inside's easy. It's x squared plus y. The outside, I'm just going to generally refer to it as u cubed. Okay, so how do we take the derivative of u cubed? 3u, so I'm just going to keep this, squared, times the derivative of u now. What's the derivative with respect to x of x squared? 2x, plus what's the derivative with respect to x of y? Y prime. Now, that is the left side's derivative. The right side's derivative is way easier, y prime. Okay, can we all agree that unless there's a reason to state it, can I just say the derivative and we all will just constantly assume it's with respect to x? Do you guys understand why I'm stressing the respect to x part so frequently? So the d dx for sure, but the dx is the with respect to x part. If I tried to do this, what's the derivative? It's x prime. Now, you can't say it's 1 because the variable that you're trying to use the power rule with has to be theta. If there's no theta in here, we don't know what it is. We assume that we can probably solve x in terms of theta. But if we don't know, if these don't match, we can't do it the regular way. And that's why I'm stressing when we're doing d dx or dy dx, I don't know the derivative of this with respect to x because there's no x in it. But I know it exists, and we'll just call it y prime because that's what the derivative is. Okay, at this point, it's just a matter of some ugly algebra, right? So help me out here. I don't really want to, but what do we have to do? I want to get all the y primes on the same side, right? Unfortunately, they're all stuck to this mess. I have to distribute. There's no way around it. Like, to be able to move it around, that's the option. This one, when we distribute it, I'm not actually going to FOIL everything out, just for the record, but I'm going to think about this first term as being 3 this, just for the record. So here we go. This one, I'm just going to call this 6x, x squared plus y squared. And I'm going to give us a second to make sure that we all agree and that I didn't make, bless you, some silly mistake in my just distribution. If I did these two, I can see the 6x shows up, 3 times 2x, and then I have an x squared plus y squared times 2, but it's already taken care of this. I think I'm good. Okay, we've just distributed. I'm not going to FOIL everything out because yuck. What about the next one? And I would probably write this in a stupid way if I were just doing it on my own. I'm actually going to show you the stupid way, and I think you guys will all agree it looks awful. I don't know if I'd really do this or not. It looks awful. It looks dumb, right? Why? Yeah, like more natural to say 3y prime than it is y prime 3. And now that I've written it, I probably wouldn't really do this, but I'm going to keep it here since it's already there. Can you see why I would possibly suggest looking at it like that? Like, it's terrible, but why would I even take the time? If I hate it so much, why would I write this here? Why? Like, what is this going to do for you and try to help you avoid or see? If you don't see it yet, you will here in just a second. I want everything with y prime on one side, right? How do I move that ugly thing that I just wrote over to the other side? I'll just subtract it, right? And now, if it wasn't clear before, Whether or not you do this is entirely up to you, but I hope that you can see the benefit in writing it in this terrible way. Y prime minus y prime times 3 times x squared plus y squared. If I want to take and solve for y prime, I have to get it out of there, right? And by writing it in front, it makes it even more clear that we can very, very easily factor it out. Now, you could probably, and I hope that you can see it even if we didn't put y prime in the front, but if you struggle to see where we can factor stuff out with things, this makes it super obvious. What can I factor out of the right side? Y prime, and then I'm going to do another big step. Instead of writing it y prime times 1 minus 3 this, can we all agree that the next step would be to do what to each side? So, and I'm going to undo this here in a second, but this is what would remain if we had factored, right? And I think, and I can't get a read on you guys, do we all agree that this is what left behind when I factor it? I forgot to write parentheses, but I'm standing away from the board right now. If we can see that this is what's going to factor, can we all agree that we're just going to divide by this immediately? So when you're doing these little time-saving things, obviously show work if you're concerned about making mistakes. But when I do problems, and I assume now that I'm mentioning when some of you guys do problems, if you can say what would be left behind and you recognize that we're just going to divide by it, I think I just divide by it here and then imagine what's left behind. 1 minus 3 x squared plus y squared. And we would get the exact same thing, and we just saved a line of work, which isn't a huge deal, but when it takes 20 seconds to write a single line because these problems are so gross, if you did it for 20 problems, that's 400 seconds, right? Like there's time being saved. Cool. Is this what they got? Hey, it is. They do the weird thing again where they factor a negative out of the denominator for some reason. Not sure why they're doing it. You could. I wouldn't personally. All they've done is they had the exact same thing, but instead of 1 minus, they factored out the negative and moved it out front, so it could be 3 and then minus 1. I don't get it. I don't see the benefit to it personally, but cool. Now, they're going to include these caveats every time. Why would they care about that? Yeah, they just saying, hey, make sure you're not dividing by 0. Cool. All right. I like these problems. You probably don't. I love them. Do you like them? I don't know. Do you have any strong opinion on it? Does calc feel like it's getting legitimately like more challenging or just uglier? I think both. Word problems will start up soon. All right. 25 secant squared x minus y over 1 plus secant squared of x minus y. The key to this problem is recognizing that the derivative of tangent is secant squared. Are we just already halfway through? Are we going to spend today just practicing some more of these? I'm cool with that. I even have a whole list of problems that we can practice with, which is kind of neat. Okay, a couple more, and then like I'm fine with just working problems today. 27 sine y over 1 minus x cos y. Why would you say Makisha's a nerd, Raphael? Interesting. That didn't really happen, just for the record, those of you listening. Thoughts? Going well, going poorly? You don't have to shout to everybody, just thumbs up saying, yeah, it's going pretty well. Thumbs down says, bleh. Anywhere in between. Okay, well, nobody's like crying in the corner with their thumbs down right now, so that's a good sign. 53 is hard and 55 is hard, or just one of them is hard? So that's, let me ask the more, 55 was hard? 53 is okay? Because I think we did a problem almost identical to 53 yesterday. I think we just used 2 instead of. Yep. Negative x over y is the derivative. And then when you plug in the point 1 comma 2, you get negative 1/2. And then when you get the tangent line, let's see, y minus 2 is negative 1/2 x minus 1. Okay. And then on C, it says graph it. Did you guys graph it? Okay. Now graphing can be, did you draw a circle and a tangent line to the circle? I'm cool with it. I'm good with it. Okay. 55. Here is this one. Ooh, x squared minus y squared. That is no longer a circle because x squared plus y squared is a circle. X squared minus y squared. I don't want to spoil the surprise. We'll see what it is. I don't know off the top of my head. A sideways parabola, I think. I don't know. We'll find out. All right. 55. X squared minus y squared equals 8. 55. X squared minus y squared equals 8. Now, at this point, if you didn't do 55 due to time constraints, I'm cool with it. I want you to do it now. How many of you guys have 55 like halfway done or all the way done? Okay, so I'm going to come and check your derivatives real quick. Everybody else, I'm going to give you a moment. I want you to find me the derivative with respect to x of these two sides. And for tough crowd. 2x minus 2y prime equals 0. Okay, I'm going to add my 2y over. I'm going to divide by 2y, and I'm going to get x over y equals y prime. Okay, that's part A. Part B, it said do this at the point 3, 1. So y prime of 3 comma 1, or if you would rather, dy dx at the point 3 comma 1. Same thing. So let's see, that's 3 over 1. Hey, that's easy. It's 3. What did I just find? The slope at the point 3, 1 of the tangent line is what? 3. On C, we were asked, I believe, to what? Find the tangent line? Okay. If I have a point and a slope, piece of cake. Y minus what? 1 equals 3 times x minus 3. Okay, and then it says graph the tangent line on the same axis as the graph of the equation. Okay, this part, I think I know the answer. Did you guys actually graph this by hand? Did you use a graphing calculator? How did you do it? Desmos, and I'm cool with that. Could you graph this by hand? So I can't do it from the implicit form. Do you guys agree that if we wanted to graph it, this feels like a natural first step to rearrange it? And then we could solve this by doing what? Square root. So I'd say y is equal to the positive square root of x squared minus 8 and the negative square root of x squared minus 8. And then we could get values and graph this. You could. Now, it's not going to be super nice, but you certainly could. X squared minus 8, sorry, x squared. What's our original problem? Minus y squared equals 8. There we go. X squared minus y squared equals 8. Let's just double check. X squared minus y. Hey, there's our graph. It's a lovely, that will change it a little bit for sure. Why do I have all these blanks? I don't know. Cool, there it is. And I'm just going to check here. We found y minus 1 equals 3 times x minus 3. Does that look like a tangent line to you guys? I'm convinced. We are good. Cool. Where was the challenge on that one, just out of curiosity? Because 53 and 55 were the two that, like, there were some way harder problems than that on the way through. The what, Angel? The graphing. If you had time on your hands and were bored, you could certainly graph this. I know that it's never going to work anywhere between root 8 and negative root 8 because this has to be greater than 0. Like there's, yeah, cool. All right, so I have some more problems for us, and we're just going to get some practice today. we're not going to do the Jeopardy today in the interest of doing some of these. So here we go. We could still make it a competition. How many of these do I have? 1, 2, 3, 4. All right. Instead of giving you guys whiteboards, I want you to have a blank sheet of paper in front of you. What would you prefer?
Boys versus girls. Oh, yes.
4 girls, 4 boys. Okay, let's do it. Yeah, really, like, there's the only prize that we're going to have is bragging rights, just for the record. I will not compete. But what's going to be weird is I'm going to make you 4, at least 3, if you can't see this board. Scratch that. I'm going to make you 3 move over there. The boys go over there real quick because I can freeze this screen so that you guys can't start working the problems before I want you to see them. Cool. So if you guys want to do groups, that's fine. Have a blank sheet of paper. We're just going to do little few fun problems here. Okay. So, however your teams are, if you want them, I'm cool with it. If you don't want teams, I'm also fine with that. But we will keep score for no reason. Points are made up and they don't matter, just for the record. Nope, stay over there, because I'm going to use that screen. I was backward. I made the boys move instead. All right. So, problem. And just a little Jeopardy game. And we'll keep score over here. What are our teams? Are you guys teams? Are you individual? Everybody has to work the problem, even if they have teams. Okay. You guys could legit do 4v3. Like, I don't care. I'm fine with it. As long as everybody's doing the problem. Okay, if you want to move your desk, you're in a group then. I don't know the symbols. Is this one women or boy? Anybody know that symbol? Oh, you can't see it, right? My screen's frozen. Okay. Boys. You know what? No. You're not boys. You're men. And you're not girls. You're women. Look at that. All right. So, for your first problem, y'all ready? Everybody has to be able to do the problem, and here we are. If the sine of x squared y equals x, then what's dy dx? Cool. I will pause this. I will get 2 minutes is our time. Don't know that we need the full 2 minutes, but those of you watching on the road, I would encourage you to work these problems. I'm also going to freeze the screen, and I'm going to work it, and we'll compare our answers. So pause it now, and you will see the solution in 3, 2, 1. Weird. All right. So as we look at this, this is my sloppy notation right here. This is just me saying I took the derivative with respect to x. Now, as we go through this, right off the bat, what I recognized, and I imagine what you recognized, was that we have a chain rule. And I saw you guys using the chain rule, which is good. So check it out. The derivative of the outside is cosine. I don't touch the inside. And then this was the most common mistake that I saw. I think both groups made this mistake initially. When we want the derivative of this, it's a product rule. Okay, so first times the derivative, first d second plus second d first comes out to this. Still all equal to 1. And then I just looked at this and I said, well, I want y prime. There's only one of them, so I'll divide both of them. At this point, the second I wrote this, I didn't know how I wanted to write it. And I still didn't know even after I looked, but I'm in my head already thinking, gosh, 1 over cosine, that's secant. So that thought is already present in my head at this point, but because I have choices, I haven't changed it yet. I then just simply subtract this from each side, and then I actually started to try to think about a common denominator stuff, but then again, I avoided this and I stopped doing this because I looked up at the answers and saw that none of them was going to match if I did it that way. So I'll simply subtract this 2xy from each side, and if I get here at this point, divide by x squared, I realize that, hey, my answer is really, really, really close up here to one of these things, except I just needed that secant instead. So I made the change from cosine of x squared y to secant x squared y. And I did that for 2 reasons. 1, because the answers were up above. 2, because if I didn't do that, I'm going to have a fraction with a fraction, and that's kind of gross. So I would like to avoid it. As soon as we get there, it is C. Men, nice job. Haul away. Well done. We're going to do a half a tick here because you guys gave me the answers eventually. Cool. All right. There's no real competition, right? Like the goal is we learn some math and we all win. Cool. We got time for another one. All right. One more. Let's see. And eventually we'll certainly do all these. Ooh, boy. I like this one. Okay. Just for the record, I'm not going to do the freezing thing. It is number 8. Just kidding. It's number 9. I want number 9. Psych. Number 9. I'll try to zoom in for you there, JJ. The limit as h approaches 0 of the cubed root of x plus h minus the cubed root of x all over h. This is a 30-second multiple choice problem. If I saw this on the test, this is an instant. I'm already locked in. Just to check, is anybody actually doing the limit right now? If you are, quit it. Because check it out. We don't need to do the limit. I see up there, and I'm going to use different notation, but on number 9, what I see is f of x plus h minus f of x all over h. And I'm taking the limit of that. Now, I change it to f instead of the cubed root, but you guys see the same thing. I plugged in x plus h for some function, and then I subtracted it with just an x plugged in, and then I divided by h. Now, the limit f of x plus h minus f of x all over h is how we define what? That is the derivative. Can you tell me what the function that we're taking the derivative of? What is f of x in this case? It's, say it again. It's the cube root of x, right? And I can see that. One, I recognize this x plus h thing, but right here is f of x. Now, if you're struggling with this, even still, if you recognize it saying, give me the derivative of x, the cube root of x, it's saying find the derivative of this. How do we differentiate this? Not rhetorical. It looks ugly because it's a fraction, but it's no different than x squared. What's the power rule for derivatives? It goes to the front, 1/3, x to the power of, we subtract 1. Now, it's gross, but 1/3 minus 3/3. Do you guys agree it's negative 2/3? And then if we click back over, let's see, it's that one. Well, 1/3 x to the negative 2/3. What happens with the negative exponent again? So this is really 1 over 3x to the 2/3 if we want to keep it positive. And let's just check. Is that one of our answers? Ooh, careful. Did I make a mistake on my stuff? No, we're good. So which one? What's the difference between B and C? If I'm taking a cube root, do I care if the number is positive or negative? -1 cubed is -1. I can take a cubed root of -1, which means it's not C. I don't have to have it be greater than 0. Only thing it requires is not 0 because it makes me divide. B is our answer. Cool. All right. Tomorrow, thinking ahead because class is just about over. Tomorrow, we will have a few more people back, which is nice. The implicit differentiation, it's tough. Do we want an extra day now, or do you want to have like let it ride? We'll keep going, and then we'll hit implicit differentiation stuff. We'll probably do several days of review before our test here. Thoughts on that? Do you want to just do another full day of implicit differentiation tomorrow? Okay, I will have a handout for you, less of a game, or realistically, it'll probably just be these problems that we'll spend some time working together. But cool. You guys get 70 seconds to just kind of chill for a minute. Or I guess a minute and 10 seconds. While we're waiting, why does this not work? don't understand. Click it. Click it. Click it. Nope. All right, whatever. Okay. Sweet. Super weird in here with only this few people. Let's see. Riley and Leanne, I hope you guys are feeling better. Mickey and don't say it. Sean, I also hope you're feeling better. I'm trying to think of who's sick and who's. I don't get it, Vincent. I just don't get it. All right, so now I had a chance to think. Sean, Riley, anybody else sick? Leanne, I hope you're feeling better. Sean, I hope you're feeling better. Abigail, Mickey, I hope you're having a nice time on the trip. Delilah, I hope your ACT went well. Goodness gracious. Cool. Later, Raiders.